Which brings me to the regulations. This is what most of you should have received at some point. I cannot remember that I received it ever in my scientific life, but I'm sure you have at some point. This is what I talked about before. There are compliance guides. I show here the examples for ETH and EPFL. So the compliance guides are the ones with the funny pictures in front. And the guidelines for research integrity. So even without the regulations from the SNSF, there's already some regulations you should follow. And I just pointed out here some information from the compliance guide of ETH, which says that all ETH members are required to integrate the general conditions and internal directives into the work process. You are asked, or for example, your project manager is asked to play an active role in guiding and monitoring junior. Yeah.
Who's handing this out?
I don't know. Which brings me to the point that they say, in the research context, the project manager plays an active role in guiding and monitoring junior scientists. So I'm not sure if it should be the project manager that should hand this out. Do you hand it out?
You just, no, I don't. That's why I'm asking. I think I got it by mail.
Yeah.
Okay.
Once we register.
Okay.
Once you subscribe for the PhD thing, you get that by mail.
Okay. So yeah, I never remembered getting one, but yeah. I mean, if it comes in the beginning, when you're new, when everything else is new, what do you do with this email? You trash it. Or you put it somewhere that says, I have a folder that says tips and tricks.
You get a hard copy.
Yeah, hard copy.
Oh, really?
It's nice.
Yeah.
I never got one. But actually what is pretty important here is that it says the project manager of the project you're working in is responsible for teaching you what to do. So they should be guiding you. Should I point out to you now? No. So just if somebody tells you, and that happened to me, that somebody tells you, find your own way in organizing your research data, no, you're not alone. So we always vote for the fact that you should have maybe a common strategy in the research group, or at least discuss it to get a kind of guidance. So the junior scientists should be given appropriate guidance, and what is for me most importantly mentioned here, primary data is carefully archived. That's it. Nothing more in there. That's the sentence, but that's it. So I added a lot of links to these slides. We will make them available. You can, in case you miss your copy of this important guidelines.
Why does it say carefully archived?
Well, you could say I use my private laptop, and I do a backup once a week on my private hard drive somewhere, and that's it. But is this carefully archived? It should be actually archived at the place where you work. So you should have an institutional kind of archive. So saying for the very first data collection, the server is fine. But I know a lot of examples where actually data goes to private computers and are not carefully archived. The next point is, maybe that's more going into experimental science, is all these people that use paper notebooks in the lab. In most cases, I would say in 95% of these cases, these lab books are never saved in any kind of way. There is no backup, because what people say is, oh, these paper notebooks, they are so super important to us. You say, yes, are you doing a backup? No, but we use them and they are really important for us. Yeah, so what happens if your lab burns? No, that doesn't happen. Well, when I was a PhD, the lab next to me burned 3 times. So, it's maybe not a good example, but just to say these things happen. Yeah. So you should, that's why I asked in the beginning, what is data? Because such things are also data, and you should always also carefully archive them because they contain primary data.
Sorry, what is the best way to archive a lab book? Because I'm just too lazy to scan it.
Okay, I have 2 ways. One I will come to later, and the second is really scanning it.
Okay.
But for scanning it, you really have to define rules. And you have to have these rules in all your group, that everybody's doing it, and the responsible that's doing the scanning. But yes, scanning it's the, or you could change to an electronic one.
Well, the thing is that we have these clean room books, which we are not allowed to take out of the clean room or put it into an environment which is not clean.
But once
Okay.
you finish the full notebook, you can take them out.
I don't know because there was a process defined. But yeah, I can make an escalator.
Yeah.
Okay, thank you.
You're welcome. Yeah, we can discuss this later because that's what I'm also really interested in.
Okay.
I would shortly come to the guidelines for research integrity, which are telling you a bit more about how you should work. So, at ETH, research is founded on intellectual honesty. Researchers are committed to scientific integrity and truthfulness in research and peer review. Again, all other things you can find at these links, but I guess that's the most important things. So to sum this up in short, what are roles and responsibilities? You are all project members, PhD students. You should all adhere to the principles of good scientific practice at ETH. You find them in the guidelines for research integrity, and all steps of treatment of primary data must be documented. That's also written in there, in a form appropriate to the discipline, and results must be reproducible. So this is not something that's new. It's written in these research integrity guidelines. But your project managers, professors, have also their roles. They are responsible for the data management, so as I said, whenever you have a question, whenever you don't know what to do, you have to approach your supervisors. He has also to ensure that all research project participants are aware of these guidelines, more or less. And depending on if it's a professor or group leader, so they determine together which departed project members still have actually access to the data, because that's also a big issue. How long do you have access to data, primary materials, or not? What I also didn't know, what was new to me, is that there are also some guidelines on using cloud computing or cloud services in general at ETH. So there is a regulation that says that removal of sensitive data at ETH is not permitted, and ETH Zurich must remain access and control over such data all the time, which is somehow not good. The use of cloud and social media services in research for exchange with other researchers and so on and so forth is permitted, as long as there is no sensitive data. So you could use it, but still, especially ETH also offers other services you could use. So again, the links. A short excursion to intellectual property rights. What you should need to consider is respect the rights of others. That should be also something that's common sense, but that includes third parties and also other individuals you work with. And in any case of doubt, always seek permission, because it doesn't do any harm to write an email to anybody, to ask for permission to use somebody's data or not, but do it, even in case there is a CC license assigned, and you could still seek permission. And note that according to ETH law, ETH reserves most immaterial rights in works by employees, and also when in doubt, there's also a place you can go to, that's ETH transfer. I'm sorry that this is like really ETH focused, but yeah, that's what I know so far. EPFL people could actually approach the ETH library stuff. So they have more or less the same unit bureau there where you can approach for services. And most other universities are starting to establish these services as well. So most universities establish a research data management section. They are organized sometimes in different ways, but most often they are either attached to the IT services or to the libraries. Yeah, and make sure to keep sufficient rights, for example, regarding open access publishing or patent applications. I will come back to this later. In short, to privacy rights, we are not specialists on that, but we added some links that can guide you either to Swiss data protection law, but also you can approach the ETH, I think the Ethics Commission, that can help you. So whenever you have a question regarding law, you can also either contact the law department or the law section at your university or the ethics commission. And we discussed this also outside already, so appropriate anonymization might be required. Deletion of datasets must be possible at all times, and the study subjects need to sign a declaration of consent. So that was the toughest part of the afternoon. The rest is going to be a bit lighter, I hope, because we're going to data management plans. So for those of you that haven't heard of it, do you have an imagination what it could be? What should it outline? Yeah.
I guess just a general strategy what happens to data at certain points in your pipeline.
That could be what points in your pipeline?
Like when I'm done with the project, where do I go with it? While I'm doing the project, where is it hosted? What is the backup strategy while I'm working on it, and stuff like that.
Yes. So it's a brief plan, and really I pointed out it's brief. So I had people coming up to us that had 10 pages. No, that doesn't need to be. It could be 2 pages. It should briefly line out what you do with your data during the course of your project, and it should define what data will be collected, how you collect it, where it will be stored, who's responsible, how it will be shared, and how the data will not only be shared within your section, but also with others, and how it will be in the end preserved. So really what I described along this research data lifecycle. And I also mentioned that these plans are mandatory, so there's no way to get away from this. So you have to get used to it. And I was asked actually by the conveners or by the organizers of the summer school to quickly say something about the Swiss National Science Foundation. For those of you that do not have an idea about this, so I took that from their webpage. They support scientific research. They support it in all disciplines. Actually, last year they had almost 6,000 projects with 16,000 researchers inside. It's not. It was not planned that those mean birds represent the SNSF, but maybe that's true in some way. Yeah.
Do you write this plan for every project or for every data set? Because you might need the same data sets for different projects.
It's for every project. Yes. So what actually happens is, so the core task of such funding agencies, such as the SNSF, is to evaluate project proposals. So what happens if you have a research idea is that you go to a funding agency and apply for a proposal, and that could be either projects that run several years. They have different fields of funding, so they either fund projects or individual researchers and their careers. So at any step of your career, you can ask for a funding that supports you in getting further in your career. So you write it for your project. And even if it's different kinds of data, it will be all in one plan. And also if you collaborate with another institution, this will be also written in that plan. So one example would be you have a collaboration with EPFL, and data at EPFL is differently stored than at ETH Zurich. You will mention both institutions and both ways how to store data and also maybe how you exchange data. So yeah, in 2017 they awarded more than 1 billion of money. They say that they use the principle of competition. So if you look at the numbers, and I will show you those numbers in a second, the run for funding is actually competitive. So about 50% of the proposals make it, 50 not. That's also true, for example, for the postdoc mobility grants. So if you apply for one, your chance is 50-50. And they say they particularly pay attention to the promotion of young researchers, which is true when you look at the programs that they offer. So just a few statistics. So the money is more or less evenly distributed between biology and medicine, and mathematics, natural sciences, and engineering sciences. They have statistics for ETH domain and universities. But this one is maybe a bit more interesting. So I was talking about they have this project funding, where like about half of the money goes in, but then they also have the like programs, which I think includes the national programs. Then quite a big part on careers, on promoting careers of young researchers, and some parts for infrastructures, and a very small part for scientific communication. All right. So in 2017, the SNSF was actually promoting a new policy on open research data, which caused this big confusion why and how you should do these data management plans now. So that's now 1 year ago. There's still, at some research groups, a big confusion on how these data management plans should look like and how to publish the data. And one part of this open research data policy by the SNSF is the data management plan and the implementation of it. So what they say is they want that you plan and document the life cycle of data, but of course this doesn't mean that before your project you should have a finalized plan of how to annotate, backup, store, and so on your data. So it's clear that this is a living document that has to evolve over time. In the ideal case, you don't need to do anything more than just writing down your best practices. So how you already work in the lab, how you already organize your data. Usually the infrastructure is already there. Only it is more difficult if you're new somewhere. Yes, I agree. But in the best case, it should be your best practice. You should offer a long-term perspective. So we have research groups that planned now, or that really did a template for always using it. So they defined, okay, what data are we creating, and they just substitute like small parts of the text. So just simply outline how data is generated, collected, documented, shared and published, and preserved. And as I said, the plan could be updated during the course of the project. What is not mentioned here is to make data actually available for the public and to see what data is there, you need to publish that plan somewhere. And for example, for the Swiss National Science Foundation, there is this project database, and at the end of each project, your data management plan will be published. So people going there looking for your project can see, okay, I can find the data there, it's stored like this, and it's treated like that. So also to keep in mind, and you will be reminded also by the SNSF, at the end of your project, finalize also your data management plan so that people can find your data. And all this is also connected to the fair data principles. Again, making data findable, accessible, interoperable, and reusable. So that means you should also, I think you also need to tick if the repository that you've chosen is actually fair. I will not go too far into detail here. I just mentioned the publication here, where you can find the enlarged version and details on the fair data principles, because each of the 4 letters has several points that define what makes data findable, accessible, interoperable, reusable. So I just added here some more information to support you. There are, of course, documents by the Swiss National Science Foundation. If you want to take your time, and also for other funders, and you go through and you try to understand what's in there, what you need to do and what not, that really takes a lot of time. And is annoying and often confuses researchers more than it helps. What we did is set up guidance that helps you fill out these data management plans. So that has also examples, questions, contacts, and so on. But we are also there to help. So our job at ETH is also to review your DMPs whenever you have questions. Also on data management in general, we can come to your group and give you advice. Quickly to other funders, again, together with EPFL, we have a data management checklist that can be used also for other funders. I added links for a collection of DMP examples. At ETH Zurich and University of Zurich, you can get also help at the EU Grants Access Office, and especially for the Horizon 2020, you can also use a DMP online tool. This is not that helpful for the SNSF, as SNSF has its own special thing, so you fill in the data management plan in the online tool, which makes it a bit annoying. Yeah, so that's what we offer. And this is also the point, I think I also see this a bit as a chance in a research group, because lots of research groups start now to consider what they could improve in the future, also in terms of reproducibility, for example, and what tools they use. So self-critical questions you could ask yourself is what enables us to reuse data of others, what could we improve, and what allows us to trust data of others. This is maybe not such a point in computational sciences. I know that it is in some experimental areas, but it's just a good opportunity to think about. And also see, is this true for your own data and what is missing? What I also find important is really pinpoint to your group leaders or professors that it's also their responsibility. And what I find a nice strategy is really defining somebody that is responsible for data management in the group. That doesn't need to be the project or group leader. In our group, that was the technician, because he was most familiar with how to annotate and store and back up measurement data. You can also document these rules, which makes it simpler for new members in the group that come to introduce them how you manage your research data.
So then, the solution, what is OpenBIS? So remember, we are still in the part on active research data management. And again, OpenBIS is a solution that was developed with the scientific IT services at ETH. So what it actually means is, sorry, you go back. So BIS stands for Biology Information System, ELN for Electronic Laboratory Notebook, and LIMS for Laboratory Information Management System. So what it could basically do is, when you are in the lab and you collect data, you could actually read in the data into OpenBIS. At the same time, you could put protocols, standards, lab notes, all in there. It can be linked to Jupyter. So it's a fantastic tool overall. So it's a platform for managing information, so scientific information. It supports your research data workflow. It can be used, or is mostly used, in life sciences. So this is where it developed, actually. But could be also used in physics and environmental sciences. And it's used mostly at ETH because it was developed there. It is used at Swiss and European universities and a few companies. So also here, I won't go into detail, but the story of OpenBIS is actually long. So its development started in summer 2007, and since then it evolved quite a bit. So I will just jump over the next slide and tell you that this service is available all over Switzerland right now. So if you have the feeling, okay, we need an electronic laboratory notebook and something that integrates data and Jupyter and could also provide big data links, then you could contact our colleagues from the scientific IT services at ETH. So they have the mandate to provide this service to all ETH, as well as to all scientists in Switzerland. So what they actually could do is provide this OpenBIS basis to research groups. They can also customize it, so really based on what you need, what instances, what links you need, what kind of research data you have. They provide then the initial training, continuous support, and they could also provide you predefined or pre-filled DMPs, so data management plans, for the OpenBIS users. So you get actually a plan that tells you how your data is stored in OpenBIS and where it is backed up and so on and so forth.
Can we still out? No, or can you still hear the back? Yeah, okay.
Okay, perfect. So what they could add additionally is the database customization, the migration of existing databases, instrument integration, and so on and so forth. I really don't want to make an advertisement here. It's just that there is a service where you could switch from paper lab notebooks to something different. There are other electronic versions. So there is also the version that you simply use OneNote or Evernote or whatsoever. But be careful with this because, first of all, you need to check where this is hosted. So there's a OneNote version that is still hosted at ETH, as far as I know, but that's running out in a few years. So then it's somewhere in a cloud, and I'm not sure if you want to have your lab notebook in a cloud somewhere. So this might be a good thing to switch to. And as we have an OpenBIS user here that could tell you potentially more than I do, you can approach him in the evening. Just another thing for those people at ETH. So the instance at ETH will be also renamed into ETH Research Data Hub. That should happen now in September. That should offer then basically this OpenBIS services as I described them. Should be a data management solution available for all research groups that allows to document and annotate data, create inventories, facilitate knowledge sharing and transfer, and sharing with collaborators. So now we come to the limitation. There's only 100 gigabyte of storage for free, and the rest will be charged or priced competitively. Don't ask me what this means, but yeah, so there is a possibility. To this, I would shortly like to have an excursion of file sharing tools. That's what we usually also present in our workshops and so on, if you don't know where to put your stuff or where and how to share files. So at ETH, you would have the Polybox or Cyphex. At Switch, it would be Drive and File Sender, which we recommend because data is stored in Switzerland and the security regulations are fulfilled. You could, for example, also use Dropbox, which is only conditionally recommended by us because data is stored in the EU and the USA. Security regulations are only partially fulfilled. And as said before, never store sensitive private data there. But that is also fulfilled or actually preconditioned by the research integrity guidelines and the compliance guide that says, that says do not store this data somewhere else than at ETH servers. Just to clarify this a bit more, so at ETH you would have the Polybox, which is similar to Switch Drive, and Cyphex, which is similar to Switch File Center, for those that are not at ETH and so on. All right.
Can I have a question?
Yes, sure.
To the previous slide. So what is exactly the difference now between the Switch Drive and Polybox? I'm not at ETH, so I don't know these two anymore.
Okay, so from my understanding, the Polybox is just the safe version of the Dropbox, and you can use it only when you're a member of ETH, and the compliant part at Switch would be Switch Drive, which you can use not at ETH, but as a member of any other university in Switzerland.
Okay, but it's essentially the same thing.
Yes.
It's a file system where you can, it's like a Dropbox.
Yes.
File system.
Yeah.
Okay.
That's what I understand from it. Am I right? Yeah. Yeah. So the point is that ETH doesn't have to switch instances, but then they own. Yes.
A different question about the previous slide. Is there any
Wait.
specific reason why Google drive is not listed as like on the right side in that category? Like some major drawback I'm not aware of?
No.
Ah, okay.
No, that was no intention.
Ah, okay.
That was.
I was just curious. I think that's
Yes. Yes, you are right. I would have added it on the right side, but yeah, it's just not. It just didn't appear. You would put it to the right side as well, right? Like to the.
Yeah. Okay.
Just to. No, but you know there are different opinions on that. So, yeah. Ivica? No? You were just pointing. Okay, thanks. All right. With this, I would like to go a bit further and see what it takes to understand someone's data. So now we looked at actually what kind of naming conventions you have, how you do versioning, and so on and so forth. So that's all valid for your own data. But what do you need from other people's data to understand them? So what I initially planned to do and what I still plan to do is a mind map. And who is using mind maps, or who is using mind maps? That's one, that's two, that's three.
For what?
For anything. Okay. Who has never used a mind map? Okay. Yes. So that so I included it, I think, in the first draft of the presentation when I was showing it to Athena and Ivica, and they were asking me, but could you explain what a mind map is or how to do it, because it's not clear. And I find it such a useful thing to structure your ideas, or also to structure the your research data, for example, like structuring how am I organizing myself. So what basically happens is you have a central idea that could be your research project, and in the first step you will define the key topics. So that could be different units. That could be on the one hand side saying, okay, I have a research project where I have actually research issues and I have administrational stuff. And then you could go further and say, okay, so what is actually all going into administrational stuff? And you would add this as keywords. What you could also do is then structure your research, saying, okay, I have topics such as data creation, data collection, what kind of publications am I planning, and so on and so forth. So I usually also used it to structure somehow publication ideas. You could color the branches, so that gives you more an overview on the individual branches. You could add images to make it really nice, and if you want to be fancy, it could look like this. Yeah?
Can you use emojis?
Sorry?
Emojis?
Yeah, sure. You can use anything. Anything you like. You can do it on paper. You can do it. There are several online tools, so if you're interested in any kind of tools, I can recommend some of them. But what I would like to do with you today is really creating it live here. So what I would like to do is to discuss with you, what does it take to understand someone's data? Of course, that's pretty simple, right? You just need the information, how it was produced, but then it starts already. But what data are we talking about? Who's the author? When was it produced? What software was used? And so on and so forth. And I would like to collect these things with you. So first of all, I would like to ask you to consider what is needed to understand your data, and what information do you expect from metadata. So what does metadata actually need to be able to be understand, or what is needed in your field? And for this, I will withdraw this thing here. I will just ask you to think shortly about it, come to the front, catch any kind of color here. And when you come to the front, try to organize your ideas with others. That in the end, we end up here with a mind map on what it needs to understand other people's data in a structured way. So critically rethinking the reuse of data is you need data, metadata, and context to use and to actually, first of all, properly understand what you're using. One example, I was using tree ring data from the 80s. Well, this person is actually still alive, and I'm happy that he's still alive so that I can ask him what he had been noting there. But there's a lot of information that's getting lost, and you should note down as much as possible to be able to interpret data. But I think we elaborated on this the last days, and that's actually also part of data management. And it does not actually, data management does not start with your own data, because at the beginning of your PhDs, you first of all often read a lot of data, of papers, and you look for other people's data maybe, and then you find that it's hard to get anything out of these data because a lot of information is missing. So you actually need to understand how they were produced. Is there enough information to evaluate their reliability? Are you comfortable actually with taking other people's data? So is there enough information that you have the feeling, okay, I'm fine with using this data? For example, for experimental data, the question is often what kind of calibration was used in the background. And also the question, will you know in a few months' time which data you used from other researchers? And do you know how to cite that data? So there are several metadata options, and Anna, she's still thoroughly working on the workshop. No, just joking. So there will be a practical lesson right after I finished my talk, which is not going to be that long any longer, where you take a look at how to actively attach metadata to data sets. And there are two options. Either you develop your own metadata scheme, but there are a lot of existing standards. So whenever possible, use a standard, because these standards are often known in the communities, so you make it easier for other people. And if there are no standards, maybe try to push to develop a standard, because that makes life easier for all. So here I just annotated one source where you can find really quite a lot of metadata standards according to the different disciplines. And you should apply it same as the naming conventions as early as possible, because the earlier you apply these standards and metadata standards, it will make life easier, and it's not that hard than attaching these data later on somewhere when you did the measurements like a year ago. Yeah, as I said, Anna will be in after my session. I forgot to add your unicorn, actually. Sorry? Today, yes.
Data that's nicely documented,
That's what the unicorn is. And that's why I will not elaborate like much longer on metadata, but I actually proceed a bit more in our program, because we still plan to go swimming before dinner. I wanted to say lunch, dinner. So you see, we already fixed quite a lot of things along the research data lifecycle. So you have information on data management planning, on data management plans, on regulations, and we go a bit to data sharing right now, which actually includes the sharing collaboration with your project partners, but it also means sharing data with others. And I will shortly point to the Creative Commons license, but these are also going to be discussed tomorrow morning. So I'm not sure if I still need to tell you what are the benefits of sharing data with others. I guess we discussed this also during the plenary this afternoon. So, I mean, for your personal career, it's actually a benefit that you get more citations, you get career recognition, and there will be new collaborations. If you make your data available as early as possible and as open as possible, there might be new collaborations coming up. But then there's also the benefits in the research community, so people can reuse your data either in teaching, they can earlier find useful data, they can build up upon your data and further develop the research in the field, and they can make new research possible. They can be more efficient, so that saves time and money to invest in other projects. But what is also coming up more and more is the public benefits. So don't forget that you're all, or most of you, I guess, financed by public money, and more data should be also made public to to people, not only to researchers, but also to others. And that has several benefits because it's not any longer the bubble of science where scientists do fancy things and it's not open and people cannot really see what you do. But people can really go to your research data, try to understand what you did, and that gives also opportunity for the so-called citizen science. Another benefit of open data for you, especially again, is the impact and the longevity. So there was a study that found out that if you make your data publicly available in repositories, you will have almost 10% more citations. And the reuse by third parties does even increase after 6 years. So what you did does not just get lost, so your publication is not like useless, but you will be recited, your data will be reused, so there's really a good sense to make this. And that brings me to the Creative Commons. So I'm not sure how familiar you are with them, and actually I'm not that familiar as well, so that would have been my colleague that should have been teaching more about, and I know that Basti is talking about this tomorrow morning as well. But so you can actually make your data available under Creative Commons licenses, and you can decide what license you want to give for the reuse of data. So for example, you can say share alike, which basically means that people share your data, share your for example, I assigned it to the slide, share alike, non-commercial. So share the data as we actually presented them. What you could also do is only CC by. That means, okay, you need to mention my name when you use my data. So that might be also something nice. There are other options saying non-derivative, some rights reserved only when putting the CC. You can share the data, you can remix data, you can make it non-commercial. So actually you can decide how open you want your data to be. What is recommended is actually the CC0. Is that what is like the most open you can do? But still I would say this is under debate. Because not everybody is happy with being like as open as possible. But that is a bit dependent on what is your personal philosophy. So I think we were also discussing before, maybe Christy, can you also add something on it? For us, we share the presentations currently under CC by non-commercial share alike. That has the reason that some research institutions commercialize their research data management service. And we don't want them to simply use the material that we invest a lot of time and money to be simply reused. So this is why we do it more restrictive.
My course is under CC by 4.
Yeah.
It was under a share alike, but I didn't want to have people who were just taking small modules from the course to have to make their work completely publicly open. It wasn't suitable for their situation. So one of the problems with when you have a more restrictive license is when you have a situation of license stacking.
Yeah.
And so the downstream user has to choose a license just as restrictive or more so.
Exactly.
So I took it back a notch so that the people who use my materials could take it, who use it in a wider variety of ways.
Exactly, yeah. Yeah.
I don't know how it's in Switzerland, but in Germany at one open source workshop, I had quite a big aha moment because they warned us. It was very open source very enthusiastic for open source. But the thing is that, at least for me as an employee, I can't just blindly put stuff under Creative Commons or OpenBSD licenses or whatever, but I have to actually ask my employer because when I create it in one work time, it's their intellectual property.
Exactly. Remember at some point in the very beginning of my slides, I was mentioning that all that you create at ETH belongs to ETH. So that's exactly that thing. So actually you need to ask your project manager what is the appropriate license. One example, we are making our teaching material available in a repository, and we have a lot of collaborators. So we send them all an email saying, okay, we need to agree on a license. That discussion is still not solved. So, and this is why I say everybody has a very personal opinion. In general, I would say the more open, the better. So really go for the as open as you can and as you want, because otherwise it makes it also more restrictive for the people reusing it. But that is an issue that's difficult to tackle. Yeah. I would leave it like this until tomorrow, so we could come back to the discussion. I have one more slide on it anyway. So there is a recommendation by the DCC that says how to license your research data, which could be helpful there. But the point is also that this document outlines pros and cons of each approach and gives you practical advice. But then the point is that it's unclear, for example, for the non-commercial one, what counts as commercial, or for the share-alike, that it introduces, that it reduces interoperability, and that, for example, the no derivatives severely restricts use. So that's really something you have to think about, but as you learned now, you have to discuss it with your project, with your PI anyway, so it's not your decision in the end, but you need to discuss it. And well, actually Horizon 2020, so the European program, advises is either CC0 or CC BY, so really the most open ones. Which leads me to, where do we deposit our data? So there are some that you can recommend or where you can look at, for example, re3data.org. And I think in my next slide I'm going to there, and you can check quickly as well, because this is a fantastic thing to look for repositories. Most of you know Zenodo already. Figshare is only partially recommended, because according to their terms of use, it is, they are allowed to delete data anytime and without notice. So maybe at some point, your data is just gone and nobody notifies you. What is actually also one thing is, depending on what research community you are in, there might be already repositories where you go to. So for my research community, that was pretty clear where to go to. That's a very small repository, but there is all tree-ring data inside that you use. So maybe if you would like to, you can quickly go to re3data.org and then click on Browse, and you will come to this nice image there, where you can check what is your discipline actually, and then check what kind of repositories are available there. So in case you're new to your research field, this also might open up an opportunity to check for other people's data. So I tried it once for my discipline. I think it's pretty complete. You find quite a lot of things. But for some communities, there are zero. I think it's a tool that's most commonly maybe used or had a lot of things in natural disciplines. But yeah, it's just one tool that could help. And in case it doesn't help and you're a member of ETH, but that's again only currently at ETH available, that's the ETH Research Collection. Can I just see hands who is from ETH? Okay, then I will talk a bit about it. And who knows the research collection already? Okay, and that's like super shocking, because it exists since about 1 year, and it's like the non-stop shop at ETH for research output. Because what actually happens is, maybe you remember when you're a bit longer at ETH, there was eCitations and the eCollection. And this is actually merged in the research collection. So what you have in the research collection is all publications of people at ETH, because what it's also used for is making the annual academic achievements and the list of publications on the ETH websites. But it has another function, and that is, yeah?
They have something similar in Billboard's called InfoScience. I think it's
Okay.
exactly.
Is it also a data repository?
I don't know exactly.
Ask, and if it's not, push and say, but at ETH you can also deposit research data. It's a good way. So at ETH you can also deposit your research data, and this is really a nice thing because you have your publication online. You can also, if you go to journals that are not open access, you can still upload the preprints here, and you can actually add the data that belongs to it. So you can make nice links from your paper to the data and add README files, so as much as you want, and also a big list of metadata. What I find even more interesting is that you can make a DOI reservation for your data. So if you plan to do a publication and upload your data on the research collection, you can call us before and ask to reserve a DOI, or you can even do it online. And then you can put this DOI for your data already in the paper, which will again increase that people look for your data because they know exactly where to go to.
So actually for ETH you can do it at InfoScience.
Yeah.
You can upload data set, but there are only 3 so far.
What's the size limit?
Yeah, what's the size limit? Let's be competitive there. We got 10 gigabyte right now. I know it's not a lot, but we increased already. So we are working on more because it's the web application. I come back to the SNF in a minute.
I have no clue.
Okay. So the point is that the Open Research Data Policy by the Swiss National Science Foundation actually says make all research data available, at least the ones underlying publications. Point. It doesn't say if this needs to be raw data or anything else. So the least you should or you have to make available is the dots underlying your graphs, and that's not a lot. So if this is the least, you can provide this then the 10 gigabyte should be enough on the research collection. There are also other ways to provide more data. Then you would have to go over the ETH data archive that I mentioned here and contact us before. But if you just want to upload 10 gigabyte of data, that's always possible. That brings me to another thing. So all data that is up in the research collection is automatically archived and preserved for the long term in the so-called ETH data archive, which you cannot enter publicly because it's just a dark archive where your data is lying. So whenever SNSF asks you to store your data or what do you do for the long-term preservation, you can say if my data is in the research collection, it's automatically archived. That's it. You can control the access of the data, so you can say, okay, if I upload data, this does not necessarily need to be open to everybody. You can limit access, you can say only delayed or restricted. That depends also on the journal sometimes. And also most important here is that this is a repository that is aligned with fair data principles. And in this year, the ETH research collection made it to, I think, 2nd place after Zenodo of the most used repositories in Switzerland, which is quite impressive as it just evolved 1 year and most of you didn't know it yet. So here again you can see for publications you just have 2 options. They are open access in the research collection or embargo depending on where you publish, in which journal. And for the research data you also have the options to limit access to ETH users, selected users, or closed access. Quickly jumping through this, so I already mentioned the DOI thing. So you have citable DOIs and the possibility to reserve them for data sets. You get a lot of citation numbers, altmetrics, and download statistics, and the links between data sets and publications. And whenever you need anything from the research collection or advice and support, just call the library. So, and I'm coming to my very last slides on long-term preservation. And this will be pretty short because this does not touch you very much right now, but might become an issue in the future. For example, if you upload your data in the research collection, you already need to consider what format the files have, because they will be preserved for the long term. So what does long term mean? We have different time horizons and purposes, and usually for research you have a short horizon, short term, from a few months to a few years for your PhD project, up to 10 years. Sorry, wrong direction. And that is again defined in the guidelines for research integrity, so we're coming back to that again, that you should keep your data at least for 10 years in case somebody is challenging your results. So then you have 10 years to permanent. What we define as long-term preservation of data is that you make data, that you store data for the longer term with an unlimited retention of data. That's especially valid for those data that you cannot easily recover again, like this observational data I mentioned, or code or software code or stuff like that. And then also data that is part of publications
that you would like to store permanently. And as said, long-term signifies any time period which spans over the actually time span of technical changes. So that might be that in 20 years the file formats that you use are not readable any longer. So you need to consider this. This is the next question, how this relates to data management. So the proper data management or its absence will determine if the preservation of your data is actually possible. So for the short term, it will be sufficient to just work with data management, but you should further think ahead if you want to preserve your data, which means for the longer period, data should be as self-contained as possible. You should maybe also include some reference output for model algorithms, so just that you can still check, because you can also have issues like bit rot and so on. So if everything is still working out fine. And then more care is required in the choice and use of file formats. So just some general rules here. That's actually common sense, but just to name them again. Use, where possible, open standards, well documented, use widely used and supported formats that are supported by as many tools as possible, uncompressed, unencrypted, keep originals and create copies in open formats. That's always a good thing to do. And don't rely on file extensions. I was making fun about this actually, but every day we receive files in the data archive that have wrong file extensions, that are marked as PDF and they're something completely different. So we have two people that deal all day with these things. It's not fun. So just to mention some images, and this is for Christy then. So images should be TIFF, text should be ASCII characters, and if you have, like for example your thesis, you should convert them into PDF A1B. If you plan to do something like this, we have a lot of instructions available, and we also help if you want to transfer files, because there are different ways how to convert PDFs to PDF A1B, and not all work out well for all files. So that's a bit tricky. But note, that doesn't mean that you should not use any other file format any longer. It's just that if you want to keep data for the longer term, consider that not all tools and programs and software and so on will be available in the future. And be aware that proprietary or undocumented formats might cause trouble. Think about alternatives, yeah, and add information like a README file. So then, like one more time again, what is really the data archive? Because I introduced this just as a side thingy. So the ETH research collection is automatically archived there, but it's actually also the archive for the ETH University archive, for the ETH Library archive. We also have the software disclosure within the ETH data archive. So when you produce software and register it at ETH, it will also go there and get a DOI. And then we have also research groups that produce that precious data, so observational data that are not easy to remeasure again. And there is a special instance called DocuTeam Packer where you can upload data into that permanent archive immediately. So, and with this I talked enough, I feel. What do you take home with you?